Hello again, statistics students, and welcome. Today we're talking about quantitative data. So these are data that are numerical. They're measurements of some kind. And in my example I used before, if you were to find the average, it would be a meaningful average. So unlike like the average zip code or an average student ID number, this is where the average actually makes a lot of sense, mathematically speaking. And so we are going to look at how do we display this kind of data. And we're going to use a couple of different kinds of graphs for it. The one that we're really going to get into today is the histogram. And as I mentioned earlier, this makes it take a little bit longer because that is a pretty technical graph. And I'm going to want to demonstrate how to make that on your calculator and adjust some of the settings on your calculator to make the histogram look good. So go ahead and grab some note paper, and we're going to get started here with a couple of slides. And then we will transition over to the graphing calculator work here in just a little bit. So this is exploring data with quantitative data anyway, with graphs. And one of the really important parts of this is when we start seeing the word describe a distribution, that's going to be one of the key tasks that we're going to be asked to do here. So, and I'll have a little bit of help with that one here in just a second. So, so we're going to construct and interpret various kinds of graphs, dot plot, stem plot, and then of course histogram. And that description, that's the big thing that's going to come up, and that's going to come up again and again throughout the year. So here's some very simple kind of graphs, and this is a really great tool for when you're first starting out your exploratory data analysis. It's called a dot plot. Now, this is, if you look at the 2004 U.S. women's soccer team, they were world champions that year. And we looked at the number of goals scored per game. So these are all the games that they played, and this is the number of goals they scored. So you can say they scored 3 and 1, then 0, then 2, then 7, then 8. They were really good. And so, and we can make a dot plot where we just put a single dot above every one of the numbers. It's just a simple horizontal axis. And each dot represents one data point. So I like this tool, especially early on, just to kind of see what does the data kind of look like. So dot plots, very simple, very basic, but powerful because it's a nice one to spot trends early on in your analysis. So I mentioned earlier, describing. And I should say this, that our author in our book, Dr. Starnes, he likes acronyms to help you remember things. And so the first one that we're really going to hit hard, and we'll be continually hitting this one throughout the year, is SOCS. So SOCS. And that's going to help us remember when we're asked to describe a distribution. The key phrase I'll say is like, okay, and what are you going to need for that? Don't forget your SOCS. There you go. What does it stand for? It stands for, the first S stands for shape. The O stands for outliers. Okay, now outliers are, there's a technical way to describe outliers that we'll get to later. For that, right now, we'll just say if you had a pattern that you could kind of see in your data, then you had one that was way outside that pattern, that would be considered an outlier. When you did your graphs a couple weeks ago, I guess just a week ago now, depending on when you're viewing this, and you had somebody in our class put down their GPA as 0. Okay, I think they've obviously just entered the number. And so while all the other data points are well away from that, there's one with a 0. We also had somebody put their height down as like 179 inches. They might have been thinking centimeters. That happens sometimes when I have people who prefer metric. So those would be considered outliers. They're outside the pattern. Center. What is the center of that distribution? Now, we'll learn later that there are actually 3 main measures of center that we're going to use. You already know them. They're the 3 M's. There's mean, median, and mode. And we'll talk more about that later, but that's a key part of your description of your data. And then finally, the spread. How spread out are they? Are they really clustered really closely, or are they way spread out across a large range? That's the spread. For right now, we'll be talking about range a lot for spread. Later on, we'll get a much better measure of spread, something called standard deviation. And if you're not sure what that is, don't worry. We will get to that. That is a big part of statistics as well, standard deviation. So there we go. When we say describe, you want to use your SOTs, the shape, outlier, center, and spread of your data. So here's an example from before. We had the miles per gallon of the different cars. And here's a dot plot of that. So the first question I would say would be to describe it. And you would talk about shape, outlier, center, and spread. Now for shape, we actually have just a few descriptions for shape. We have skewed, and we have skewed left and skewed right, and we'll talk about the difference of those shapes there. We have symmetrical, okay, so data that looks pretty symmetrical, evenly spread out on either side. We have a uniform distribution, and we have something called bimodal distribution. So in this case, you might say, well, there appears to be some skew. Now, which direction is that skew? We'll talk about that in just a second. But if you're thinking, hey, there looks like an outlier down there, that 14 down there for that Bentley, and then that 18 is kind of way down there, okay? Yeah, those are probably the Rolls-Royce Phantom and Bentley are probably the lowest fuel economy cars in our bunch here. So they're probably going to create some skew, and that would be skew to the left. That is skewed left data. So the center, where do you think the data is centered? I don't know. You know, that would be a good discussion. Normally we would put it up there, and I'd move a slider around, and we would talk about it in class. Usually people think it's centered somewhere around, you know, like 23, 24, 25 miles per hour or miles per gallon in there. The spread for right now, I would just say the range is from 14 to 33. So that's our shape, outlier, center, and spread discussion for this data set. So that's what we mean by SOTs. All right. Here are the definitions for shape, and these will give you a rough idea here. So symmetric. When we say symmetric, it's not exactly symmetrical, okay? In your other classes like geometry and stuff, it had to be exactly the same on each side. This is not that. It's going to be roughly symmetrical. Skewed right and skewed left, you can see them down there. Like I said, when the outlier is to the left side, we call that skewed left, and when the outliers are to the right-hand side, we call that skewed right. All right. Here's a couple more dot plots. Hey, what do you think that top, the south there? You think that maybe is skewed right? Yeah, I do too. For the UK, oh, sorry, that was South Africa. I see the Africa there. For the UK one, it's that one I would probably say that's symmetrical. Okay, even though it's not exactly symmetrical, it's roughly symmetrical. All right, another quick and easy graph to make. The stem plot, stem and leaf plot. You've probably made these before, so I won't belabor this too much. You separate the observations into the stem, which is everything except the final digit, and then the final digit, which are the leaves. So here's a quick and easy stem and leaf plot for a survey where they asked 20 female AP statistics students, how many pairs of shoes do you have? And so they, there's a little overlap there. I'm using Google Slides here, guys, so there may be some font problems, and I can see it over there on the right-hand side. So if you look at all these numbers, notice that they range from a low of 13 up to a high of 57. And so my stems then are going to be the tens digits, which is why they've done stems 1, 2, 3, 4, 5. Okay, then we add the leaves. So we just go across, like, okay, the first one's 50, so 5, 0. The next one's 26, so put a 6 on the 2s. Another 26, put another 6 on the 2s. Just get them on there, then reorganize them so that they're in order. And that makes a stem and leaf plot. But every stem and leaf plot needs a key. So you can see where they've added the key over here. That is an important feature because you need to be able to tell somebody who's reading it, well, what does a 4/9 mean? Is that 4.9? Is that 490? No, that's 4/9. That's 49 pairs of shoes. So you want to make sure that you include a key anytime you make one of these, just to be really clear. All right. They asked the same question to a bunch of male AP statistics students. And so we made a thing called a back-to-back stem plot. They've also introduced the technique of splitting stems here. And that's because if you had, like in the male graph, there's oh my gosh, the alignment is really off here, guys. I'm so sorry about that. You know what, let's do this. We'll talk about splitting stems in class. I didn't realize this slide was so messed up. Oh, I'm sorry about that. I may have just edited this out, so yeah, we'll just edit the whole split stem part out. Edit. So our final quantitative graph, and our most technical one, and probably one of the most useful ones, is the histogram. Now, a histogram is where we gather our data into what's called a frequency table. And then we have different classes for the data, and we count how many times we have the data points that are in those classes. Okay? Then we label our vertical axis as frequency. Our horizontal axis is whatever the measurements are in. The bars should all be equal width. And in a histogram, your bars are always going to touch. Okay? The only reason you would have a gap between two bars is if you had one of the classes that had 0 data points in it. So let's take a look at a data set and how we might create a histogram. Okay. If you have your book handy, on page 35, okay, it shows the percentage of foreign-born residents in each of the 50 states. Okay, so what percentage of the people who live in that state were born in another country? Okay. And so our data goes up to, well, what they did was they broke it up and they said, okay, let's have classes that are 5% wide. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. But notice they had to put in the less than symbols, because if we had a state that had exactly 5%, it can't be in more than one class. The frequency has to add up to 50 because there's only 50 states. So it's from 0 to less than 5%. So if it's exactly 5%, it actually goes in the second class, because that's 5 up to less than 10%. So if it's 9.99, it goes in the second class. But as soon as you get to 10%, then it goes into the third class down, which is from 10 to 15. Okay. You have to decide on that rule. You get to choose that rule. You could go from 0 to 5, and then greater than 5 up to 10, and then greater than 10 up to 15. So the 10s and the 5s could be in the lower classes too. You just need to decide on what the rule is going to be. Then we figured out how many states there were from 0 to 5%. Well, there were 20 of them. From 5 to less than 10%, there's 13 states, and so on, 9, 5, 2, and 1. Hey, while we're here, what would you think the shape of this histogram looks like? Did you say skewed right? Because then you'd be correct. Yeah, this is a skewed right histogram. All right. Okay. These are not bar graphs. Okay, bar graphs show frequency, but they show frequency for categorical variables. Okay. Histograms show frequency for quantitative variables. Don't use the counts or percents as the data. Okay, that's not the data. The data are the individual scores. Okay. If you have different distributions with different numbers of observations, you probably don't want to use exact counts. You probably want to use what's called relative frequency in your for the height of the bars, and we'll talk a little bit more about what that relative frequency is later. And just because a graph looks nice does not necessarily mean it's a good display or a meaningful display of data, and that is quite true. So we are going to go over to the calculator now, and we're going to look at how to make a histogram with our graphing calculator. So I have to switch over to a different, I'm going to switch over to the document camera. And I'm going to demonstrate this procedure on a TI-84 calculator for the purposes of the video. If you have a different calculator, then we can talk a little bit more in class on how to do that with a different model calculator. If you have a TI-89 or an Inspire, It's very similar in there, but I do want to make sure that we have time to do a demonstration here. So let me switch over to my other camera, and then we will continue. Marker. All right, guys, here we go. So we are now over on my document camera, and this is the data table we're going to be using. So it is on page 35 in your textbook. It's the same one we saw displayed earlier, where they made the histogram for us using their 0 to 5, 5 to 10, 10 to 15, and so on. But I'm going to demonstrate this with this same data set. So you may want to pause here and enter this data into your calculator. Or you may have to rewind here because I guess you maybe don't know how to enter data yet. Also, you can pause and go grab your book. You can enter the data as we go along here. So as I said, I'm going to demonstrate how to do this on a TI 84. But if you have a TI Inspire or if you have a TI 89, don't worry, I'll show you how to enter the data in, and then we'll talk about how to make the graphs when we get to class. So maybe take a quick second here and make sure you have your calculator with you, and we will put some data into our calculator, and then we will. Okay, guys, so hopefully you've had a chance to get your calculator ready to go. Here's a marker for me, so I know where to edit that back in. And as I mentioned, we're going to show this on how to enter data on a couple of different calculators, but I'm going to try to work through this so that the video is not so long for you guys to just have it happen all in one, just on the 84 for right now. So if you have a TI 89, though, I do want to show you guys how to enter the data on your calculator. So on your TI 89, you want to push the apps button. You have a button in the middle that says apps in purple. Find in here something called the stats list editor. Okay, and that's where you will go to enter your data. We'll do a lot of stuff with the stats list editor. You can see I've actually got some data in mind from before. So yours will look, yours will look more like a brand new one, because I'm guessing that you probably didn't know this was here and haven't used it before. So all you do is you just type in the data right in here. So, you know, if my first data point here is 2.8, like so. I just enter and keep entering, hit entering as we go along. It's automatically saving as you go through. So that's a TI 89. And here's my TI Inspire. And this is the home screen. And on the home screen, you can see across the bottom here, we have a row of icons. And the icon we want to start with is add lists and spreadsheets to our document. And then you can see we can just start entering our data in here. Like our first one's 2.8 and so on and so forth. Okay, now I will say this, on the TI Inspire, at the very top of your row, there's a letter. We can actually enter a name for this list. And so I'm just gonna call this example for right now. We can name it, you know, with whatever the data is later. But that way I have a list name for this thing so that when I go through and I enter all my data here, I can use that variable name example. And I'll explain more about what that looks like when we get to class for those of you who are using an Inspire. The Inspire is a fantastic calculator, but I want to illustrate this on all the calculators if needed. So on the TI 84, there's a stat button. Okay, so here's my stat button. And when I hit my stat button, I get this menu. And all I do is I go into edit, enter. And I have lists, L1, L2, L3, L4, L5, and L6 that are pre-made lists. And I'm just gonna type my data into list one, L1 right here. Okay, and so now I've got my data entered. You may want to pause right here while you're typing in data, and then you can continue on from here. So once the data is entered, you might notice on the very top row of keys, there's something that says stat plot up here. So I'm gonna hit the blue key and then hit stat plot. And it gives me a list of plots. There are 3 possible plots that you can activate on your TI Inspire. And so I'm just gonna go into plot number 1 by hitting enter. And you might see my cursor is flashing right now on the on. I wanna turn this plot on, so there we go. So I just hit enter on the on button. or on the word there. And then we go to the graph type. And there you can see there are 6 graph types here. And you see the third one over looks like a histogram. That's the histogram one. So we're going to go there. And then you can see it says X list, and it says L1 because that's the list where I entered my data. So I'll just hit enter. Okay, see, it's already there. And now at the very top right button, you see a word that says graph. So I'm going to push that button. And oh gosh, I've got some other stuff being graphed on here too, because this calculator was used by somebody last year. So let me clear that off. I'm going to go here, and sure enough, somebody's graphed the function tangent of x. So hold on, let me clear that off. Okay, now I'll go back to my graph. And I can't really see my histogram very well. That's because the zoom is different than where the data is located. And these calculators all have a really cool feature. It's called zoom data or zoom stat. I go to the zoom menu. So the top row, there's a word that says zoom. And if I scroll down, number 9 says zoom stat. On your 89, I think it says zoom data. And I think the Inspire might say zoom data when we get there later. So if you're looking for that zoom command, it's zoom data on some, zoom stat on this one. And now we can see our histogram. Now the thing about this histogram is very different than the one that I showed you earlier that the book made. Just see how many bars do we have here, right? Okay. If I'm looking across, I see 1, 2, 3, 4, 5, 6, 7, 8 different classes that they've made for this histogram. And so that's where maybe as we start to get into this a little further, we might want to be like, oh, I don't know if I want 8 bars in my histogram. I want to change it. And so we'll talk about how to manipulate that histogram a little bit later. If you want to get and try, then you have to go to your window settings, okay, and adjust some of the things in your window setting. But we're not going to worry about it right now. I just wanted to show you how to make a histogram. So in your TI-84 calculator. So I know a lot of you have TI-84s, so that's why I started with the TI-84. If you don't have a TI-84, don't worry. When we get to class, I will redo the illustration here. But on the 89, it's very similar, and then the Inspire is quite a bit different. So that'll take another run through there. So I wanted to give our 84 users a little quick tutorial and show you that it does work and makes a nice little histogram. And we can, of course, manipulate the histogram a little further later. So, all right. Well, I think that's it for our graph today. What we'll do is have you guys watch this video and take some notes, and then later on, when we get back to class, either if I'm seeing you on Thursday, then it'll be on Thursday. If I don't see you till Monday, we'll do it on Monday, and we will take a look at how we can use your calculator if you haven't already figured it out, how to use your calculator to make some histograms. So thanks so much, guys. I will see you on Thursday or possibly Monday.